mío que tú vas pasando de gabinete en gabinete, ¿no? Y el hombre me preguntaba dónde trabajaba. Yo le contaba que estaba con los helicópteros Robinson 22 de la policía de la provincia de Buenos Aires. Me preguntaba todo, todo, pero absolutamente preguntas muy profundas. Que yo le respondía hasta donde sabía, porque en ese momento era medianamente nuevo, tenía 6 meses, una cosa así. Cuando termino todo, bueno, termina todo la vuelta, me dice, bueno, un gusto. Él me dijo cómo es su gracia, o sea, esa gente de campo, ¿no? Que no te
Sí,
pregunta cómo es tu nombre, ¿cómo es su gracia? Claro, yo me había criado, digamos, en el barrio de 1,76, que cuando yo era chico era mitad campo, mitad ciudad, ¿no? Así que más o menos ese idioma no entendía. Y digo, bueno, yo me llamo Rafael, y le cuento y me dice, yo me llamo Augusto Sicaré, me dice. Entonces, bueno, le digo, un gusto, le doy la mano y me voy. Y hago 5 pasos y digo, este no será Pirincho, porque yo lo conocía de nombre. Y fue que me di vuelta y voy y le digo, ¿usted no es Pirincho Cigaret? Y me dice, sí. Y le digo, pero qué vergüenza yo contándole el helicóptero a usted, ¿no? Y dice, no, no, lo has hecho muy bien, me dice yo. Ay, es que me puse todo colorado, porque digo, joder, digo, ¿cómo es esto? Y me dijo, bueno, véngase a mi casa, me dice, yo lo invito, y yo digo, bueno, ¿qué voy a ir un día a Saladillo? Y bueno, un día se me dio, dije, bueno, voy a ir, lo llamo por teléfono, que me había dejado el teléfono, y fui. Me atendió, pero como esa gente que solo sabe atenderte, ¿no? Creo que tú tuviste una entrevista con él.
sí, tal cual.
Y, y bueno, me atendió como si fuera uno más. Y empecé a ir, los fines de semana iba, le ayudaba lo poquito que podía, aprendía un montón, y bueno, yo estaba encantado. Y eso fue mi relación con él desde el año 96 hasta, hasta sus últimos días, que yo seguía hablando por teléfono, a pesar de que me había ido, yo hablaba por teléfono muy seguido con él, teníamos estas charlas larguísimas y súper agradables, y, y bueno, nada, aprendí, él me enseñó muchísimo de lo que yo creía que en la facultad sabía, y no, yo aprendía mucho de teoría, pero él con un simple hilo y con una piedrita me explicaba todos los procesos físicos que tenía un helicóptero.
Buenos días a todos. Hello, everyone. Mohammed, you can start.
Yes. Okay. Ladies and gentlemen, esteemed attendees, and our distinguished guests, it is with great pleasure that on behalf of Aviation Engineering Society of Emirates Aviation University, we extend a warm welcome to Professor Rafael for the inaugural session of the New Talent of Aviation 2023. Today, we have privilege of delving into the fascinating realm of the future of urban air mobility under the expert guidance of Professor Rafael. His wealth of knowledge stems from a master's degree in mechanical engineering from UTN, coupled with extensive experiences as an authorized aircraft technician for airframe and power plant, licensed by Federal Aviation Authority (FAA) and Inspector Authorization License. We would also like to highlight his relevant work experience. He has worked as a fleet manager engineer, CAMO, for Airbus Group, based in Saudi Arabia from 2015 to 2017. He also worked as MRO manager for Airbus Military Division based in Saudi Arabia from 2017 to 2019. Then he was based in Spain for Squadella Aero as a senior site manager from the year 2020 to 2023. And currently he is the senior manufacturing engineer for Fokker Landing Gear based in Netherlands since November 2023. As we embark on this enlightening journey of knowledge into the future of aviation, let us absorb the insight that Professor Rafael is about to share with us. Without further ado, let's engage in this thought-provoking discourse on utility aerial mobility, a pivotal aspect of ever evolving aviation landscape. Thank you. Let the session begin. Before we start, I encourage all our participants to keep their microphones switched off. If they have any questions to be asked to our guest speaker, they can drop in their question in the chat of the video call, and then they will be asked towards the end of the session. Thank you, and Professor Rafael, the floor is yours.
Okay, thank you, Mohammed. I will start put my presentation here. Hello, everyone. I am Rafael. I'm from Netherlands right now. I will start my presentation. Share right now like this. Okay, could you see it?
Yes, we can see
Ahmed,
it.
yeah, you can see. Okay. Well, today we will talk about the urban air mobility, a little bit the past, a little bit just. We can talk about the present and the future of this kind of device that now is grow up with high intensity around the world. First of all, we have in a planet we have some urban challenge because the population is grow up, and in the future the United Nations think that all the people will be more concentrated in large city than in a no city, in the farm, or because the farm will be automatic, and maybe the people translated from the they move from the farms to the city, and the population will be growing and growing in the good or wrong way, depends. Then we have some challenge. The first one is the urban traffic congestion. We have pollution, stress associated. We lost a lot of time in the traffic. Well, it's thing that everybody knows, and every time is worse and worse and worse in big cities. For example, here in Netherlands, the place that I live is a nightmare. If you do not catch the real time for move to your house, you must do maybe 1 hour of traffic. You lost maybe 3 hours or 4 hours. That is very common in big cities. The second thing the one thing that I say is population growth is growing a large portion of the population. The expectation for 2050 is 10,000 million, 10 billion of 10,000 billion of people in the world, and if we add that everybody goes to the cities, will be a complicated situation in the cities. And right now we have a current problem in urban transportation. The urban transportation right now has some change with air pollution. Is all the cars being electric. This is some problem for the where you charge and where you move the challenge of the autonomy of the car. Well, meanwhile you have traffic accidents, noise, and all the inefficient use of resource that everybody knows. Well, for this we need innovative solutions, growing demands for mobility in cities. That is the challenge that we have in the front, and from this is the definition of a scope of the urban air mobility. This is the solution that the companies can see for the future. The concept is not just move passenger, it's move passenger and goods, but always will be an urban environment that use some cars, some kind of source will be electric, hybrid, or even or another hydrogen, for example, is almost that the company is looking for. That is really complex right now, but it will be a future at least. Well, I want to pass through the first in the past, because everything that we saw right now comes from a dreams, and the dreams is almost the engine or the fuel that move all the new challenge in the world. The first one, we have at least that the people that have 50, 60, or 45 years, we born in a world that everybody knows that in the future this will be reality. But the people of this time thinking about and make some they have some ideas how the world can be. And that is why in many countries appear some cartoons that looks weird right now, but for the people that has the mind set looking for the future will be a reality. For example, in my case, when I saw this, the Gestión, in Argentina, the name was Los Supersónicos, was amazing, because we can think about the future. The thinkers in this time plan for us, and was amazing, because we will grow up thinking about that. Many of us, we are engineer because when we were young, we were thinking about this kind of thing can happen, and we want part of this. If you see the city of the vehicles that you see there, the device is almost that the industry is looking for. You see in one picture, in this one, you see the corridors. You know, they are thinking about corridors. They are thinking about the device. They are thinking about the vertiport. They are thinking about everything that right now is almost real. It's not full real, but it's almost real. We are thinking about that. This is the vision from the 60, 70. Meanwhile, when they are thinking about that, they say, well, the future will be in 2000. I remember that when I was young, it was 2000. That is why appeared many series where the space, the conqueror of a space of this kind of device will be in 1999. But that is why the future was very close at this time. That is why the people thinking about these kind of things, like this, for example, you know, vertiport in the sky, weird machines that flying without any device more than some power. It looks very weird, but for dreamers, this was the fuel for thinking about the future. But now this generation almost pass, not pass away, because we're still living, but you know, new people come from the same ideas than the past, but it's an amount enough the people that had the same dreams, but the new dreams as different view. But if you see, it's almost the same. You see you can see the highways, the planes that can land and take off vertically, fly through the skyscrapers. You see, almost the vision is the same, but with the modern resources. That is why right now we are in the good position to start to thinking about the future as a reality. Why say that? Because at the beginning was a little bit crazy for the authorities, because the drone start to grow up in the market very fast. From China, we receive a lot of drones that flew very well. This is the result of some studies about the weight of batteries, the propellers, new engines, new technology. new way to fly, has many, the new drones has many functions that are amazing. But meanwhile, some start to thinking about why we can do this drone bigger, you know? Oh, okay, we can do it. We say the same configuration you see in the left, in the right, sorry. In the right, you have the same configuration, looks like the same drone. But when they finish that, they spend a lot of money to do this. But meanwhile, they went to the authorities, and the authorities say this is no common sense for the normal flight. It's no common sense for authorities, because they are looking for the aviation as aviation does. Means that you have planes, you have helicopters, big planes, big helicopters, balloons, you know, even you have experimental planes. But this one looks weird because, you know, if the propeller fail, it's an accident for sure, you know? That is why I did not take seriously what happened with this drone bigger, no? But the time was passing through the many people in the university to start to thinking about that, and they put this idea to running. Many young guys start to thinking about that this could be real if we study with the new batteries, with technology that we have. This can fly. Why not? Say yes, okay, can fly. That is why many people, many master degrees and in universities as a doctor in aeronautical engineer start to make a calculus, and they convert many people with some people with money, with people that interest for flight, and in every university or in every place, this idea start to grow up in a very fast direction, go straight very fast, and start to move some person in the government, because normally the people that invest this is people that have money, have many contacts, move the people in the government, and the government say, okay, this is not a joke, it's not a drone, looks like a go in the serious way. And that is why now we have all this technology pushing too much to the authorities that we will see in a few minutes. Now, I want to start with the power technology. The power technology that we have right now is almost old technology, but refurbished. Means that we have new technology in all engines. These new engines has a high power with a low weight. All of them are three phases engine, brushless, and works extremely well, never fail. Has a high power ratio. If you has a maximum power ratio for one engine, for one motor, you can put more power, and you have more power in the shaft. Means that this kind of engine support extremely condition very easily. And if you put a car engine in front of this engine, the weight power, this kind of motor win for 10 times the race. It's amazing technology. That is why we use this kind of engine. Well, right now we can pass through the architecture of the management of the power. This is the common way to use the power in this kind of device. It's very easy to see that this very common way to use the power. We start with the battery in the left one. We start with the battery because the battery is the source of our energy. The battery normally is a sum of many small batteries that we put in series and in parallel. This kind of battery has normally 300 volts, 500 volts, because you need a big density of energy in a small place. Well, when you have this battery with 500 volts, for example, you need to reduce the power, reduce the voltage for all devices of the aircraft. Means that first of all you need to put in the second step a DC-DC converter. Means that you can from direct current at 500 volts to maybe 40, 38, 28, depends, but it almost is 28 or 40 volts for the power bus. All these three devices is the energy management. You can deliver the power through the computer that give to the power bus all the power that you need. Well, in this case, the power bus distributes the energy in all plane that you can use in avionics, radar, lights, landing gear, air conditioning. Remember that the only source that you have in this plane is batteries. You don't have engine for air conditioning, for example. After that, for our draw is the only that we put focus is in the power of the engine. Well, after that, we have for one side of the connector we have DC converter, but the engine is three-phase alternative current. It's not direct current. The aim of convert of the current is because this kind of engine has a big radio of power weight. If we put a direct current engine, the engine will be extremely bigger and heavy. That is why we use this kind of engine. Well, when we convert, is not difficult to convert. We have one power controller that with the PWM connection, we can choose the power that you can deliver to the motor to the propeller or propeller in this case, yes. Well, it's very easy. It's easy to understand. Everybody knows if you have a plane, radio control plane and everything, it's almost the same except the DC-DC converter. But it's almost the same. Well, our technology from right now, from the right to the left, the technology of the propeller is almost has a maturity from more than 100 years. It's easy to do, easy to install, easy to use. The propeller is not the problem at all. After that, the motor is totally solved. It's easy, almost cheap, could be cheap, no problem at all. The brutal, the motor control and the converter and the power controller is almost easy to find in the market. The converter is a little bit complex, but many companies can provide this device. It's easy to do. The power USB is a metal copper. It's very cheap and easy to find. DC-DC converter in the market you can find very easy and you can install. Never you have problem in the plane. Energy management is the same. You have the same device. Easy to find. It's a small computer. You can buy whatever you want, and you can convert to use resource that you want to manage. But right now, the battery is a real problem that we have right now. At this moment, 2013, we have 2023, we have this problem right now with the batteries, because right now works, but do not work as we want. Why? Because the battery right now has a density. The energy density of the battery is almost the best one you can find in the market. Could be 300 watt-hour per kilogram. This is the best that you can choose in the market. Remember, for helicopters, normally if you have a rotor blade of helicopters with a big diameter of helicopters, every 5 kilos that you put in the helicopter, you need 1 horsepower. In this case, because the rotors are small, every kilo that you put, maybe you need 2-3 HP, maybe, if we are generous. That is why the weight of the battery is right now the most important thing that we are looking for. That is why we use the ratio between batteries and the weight. As I explained before, this kind of battery has almost 300 watts per hour per kilo. Okay, but right now the future is close to be a reality, because many companies are working in this problem, because many companies are demanding that this problem must be resolved. Meanwhile, the lithium-ion battery has a problem that is a little bit dangerous and very complex to put in device to fly, because many times has take a fire. That is depends. Right now it's almost safe, but could be not safe in the present or maybe in the future. That is why some companies are looking for a new solution. Right now, the one full charged one, for example, lithium or whatever lithium could be, maybe can fly 30 minutes. If we remove some batteries, or if we put more batteries, we can fly more, but it's complex to take off because the weight is too much. But if we remove batteries, we fly less because it's easy to fly, but the power is too low for flying more time. The best case scenario that we have right now is 30 minutes. The 30 minutes crash with the real thing that we have right now in the flight rules in the world. Because for visual flight rules, we have, during the day, we have to have in our pocket the reserve of the 30 minutes. Means if we have 30 minutes for flight, always we are flying, for authorities, we are flying as with reserve. We do not fly as a free flight. Worse during the night, because during the night is 45 minutes, and for helicopters, for example, it's 20 minutes. But 20 minutes means that you have 10 minutes for flight. After that, you must land. If not, you must declare emergency, or maybe in this case it's not necessary, but the flight rules crash with this time for flight. But we can talk after about the rules of flight or rules of the airworthiness. Well, the market right now are doing some experiment with lithium metal anode, lithium sulfur, lithium oxygen, foam coat. The last one is not the battery, it's a hydrogen fuel cells. Well, all of them has a high density of charge versus the weight. It's very good. This is a hope for the whole sector, because, for example, the lithium oxygen, they are declared 1,000 watts per hour per kilo. This is a very good news about the future of this kind of device. But right now, it's not a real thing that this doesn't happen yet. All this is in laboratory. They are working on it. The experiments are very high. They are putting a lot of money for resolve this problem, but it's not real yet. But at least we have a good perspective for the horizon about the batteries. nobody knows how much time we will waiting for, but at least minimum 10 years, because in the middle you have certification, many tests, crash test, 1,000 tests for that. But one of them is different. Hydrogen fuel cells. You pass hydrogen through the cells and you generate electricity. But the electricity in this case is a little bit complex because the hydrogen is too complex to keep in the cylinder. In case that works very well, 50% is electric energy, 50% is heat. Means that you need a radiator, huge radiator, for separate the energy to the heat. That is why you need to install another device that is weight, a lot of energy that you lost. Right now, this kind of technology right now is still growing up step by step, but right now we have a lot of things to do for achieve this goal. This is all from battery. We can pass through for avionics. First of all, we need to start with the end, because we are talking about the flying in urban areas. In urban areas, for this kind, the difference between helicopters and planes. Normally, when you see the accident, you see the helicopter has a high rate of accident if you compare with planes. And always say, what is the problem? The problem is the helicopter is a bad thing, so bad device for flight. It's not safe for flight. Almost is the same. But the problem is that the plane never fly in the surrounding areas that the helicopter fly. Helicopter fly between cables, trees, the ground conditions normally has problem because they blow up many things that can affect the helicopter, bags or wiring, whatever that you, wood, stones. You have many problems that you can reach with helicopter. For this case is worst, because this kind of device fly in urban areas and low level all the time. At least 70% of the time will be close to the building, close to the skyscrapers, close to another device, close to the bird, close to the wiring, close to trees, close to everything. That is why this industry are looking for a new device for control the flight. But in the middle, you need to think about that this kind of device will be flying without pilot. Will be flying alone, with a tower of no control from the tower. Will be a different level of control. We are flying in dangerous areas. But for all the things, the industry are thinking about the new approach to detect and avoid capabilities for autonomous navigation. One important thing is command and control beyond visual line of sight. This thing is what happened before and after me, because they must to have a situational conscious about what happened after, when I pass through one point, for example. This kind of device is in development right now, and for all things that the device is interacting, we have new levels of data transmission, because all that we have is not enough for this kind of planes, of helicopter, or of this kind of mobility. The industry is working in radars, the new radars, because the radars that we have do not detect, for example, a bird, a bag that is flying, has a wing close to the ground and move bags to the sky close to the ground, and you can crash with a bag that can destroy one rotor, or maybe I don't know, cover one camera or some parts for detection or whatever. Well, we can use the same automatic defense surveillance broadcast that we have. This is almost the same. One idea is to put cameras as Tesla. This is a discussion that exists right now because for both LiDAR, the LiDAR is too complex. It's a very good device. Right now, the iPhone new has a new LiDAR. It's amazing. But use one big amount of bytes that is difficult to manage with another systems. This kind of system manage is a laser that's turn around and make a 3D image for the device. It's very good. We are using LiDAR for forecast. We send LiDAR to the sky and they can see the winds. Amazing. I don't know how, but they see the winds, the clouds, everything. That is why it's very good device. Right now, the technology LiDAR is very good, but it's very strong for the system. That is why many of them choose cameras. As a Tesla detect everything. Maybe use the same technology could be a good way to manage the flight. And another one is electro-optical and infrared wavelength. This is a very efficient way to use it, but the problem is you need to focus all the time in different positions. Normally this kind of device just focusing maybe in 90 degrees or no more than this. That is why for command and control beyond visual line of sight, it's impossible if you need to see behind you or side to side. You need to install many devices of this. Remember that any device that you install there consume power for weight and power for consume of the same device, bytes, energy, and everything. That is why we need to reduce the amount of the device that we install in the plane. This is very important. And the one important thing right now about the avionics is how, well, I can ask a question about the future after this conversation. But right now is how will be the avionics if nobody is inside? Suppose that the device will be alone and you go there, close the door, and you interact with all device of the airplane, and you say, I need to go there, or wherever. You don't have more vertical speed, ground speed. You have nothing of that. You remove everything from the cabin. Okay. Air traffic management. Well, in USA, they put the new name that is human traffic management, and in Europe say US space. It's almost the same. You see different names if you check the website, but it's almost the same. If you read deeper, it's almost the same. Right now, we can talk about this kind of management because right now it's totally different as the traffic management that we have. They normally use that when you go to your airplane or helicopter, you call the tower. The tower send to you to the vector that they consider that you must to have. It depends of your flight plan. They give to you the flight path, the altitude, the direction that you go. This is the normal way that we use right now. But with this kind of device, it's totally different. Totally different. Why? Because where you put this traffic management in the city, for example, with 100 Lilium or whatever, flying through the city. It's impossible. Nobody can manage this. No human is capable to manage this. That is why they are working in an automatic system for manage this air traffic control, because they are thinking big right now about how can manage this. And well, right now they're talking about that. The NASA, FAA, EASA, all is involved. DARPA too. Many agencies are in this management. Right now, the NASA FAA, they call air traffic management ecosystem for uncontrolled operation. Well, it looks good, but nobody knows how it is. But maybe in the close future, everybody knows about that, or maybe everybody uses it, but nobody knows how this works. Because don't care because it will be totally automatic. It's the same that you have a telephone, mobile phone, you use for communicate. No, don't care how you use, what happened inside of the telephone. Nobody knows. Nobody care. For this case, it's almost the same. Well, I think that you have many questions about air traffic management, but we need to move forward. The regulatory for the regulation. Well, here at the beginning we discussed about how can convert the drone to the fly device for put one person or two person inside. Was almost a joke for the authorities. But after the new revolution in urban mobility, all the agencies, they are thinking big and seriously about this kind of way to transport the people and goods. Then, where we have in Europe, we have EASA. EASA has, in particularly, every country has his own regulatory commitment, but all depends from EASA. Almost is the same. But because EASA spend a lot of resources for make a law and make all kind of rules about the flight, about the crew members, planes, helicopters, balloons, and everything, many countries take this in consideration that almost looks good, and we can take it as many cases. For example, all Saudi Arabia, UAE, Kuwait, Qatar, Bahrain, many countries, Oman, all use the EASA as a base of the regulation. After that, every country take all the regulations, say, looks good. We can change for our country some things, but almost all the hard work, 90% of the work is done. And it's very easy if, for example, in UAE, you make a plane, you can certificate the plane in UAE, and it's almost easy to pass through EASA because almost it's the same rule. The same is for FAA. FAA has the rules that many countries adopt as maybe some of them copy and paste, but during the years make some change for example, in Argentina, ANAC, they made some change about the FAA, but the base was FAA. The same from ANAC Brazil, the same from Air Transport of Canada, all is the same. Many countries use the same consideration for the rules. Difference for China, difference for Russia, but because all is integrated in the Aircraft Transport Association, at the end, almost 80 and 80% almost is the same. And it's better for the industry. If not, will be a mess every time that you pass through from FAA to EASA, from EASA to China, or from ANAC to the GIC from France. Will be complicated, extremely bureaucratic and complicated. That is why right now almost all the law is not exactly the same, but looks like the same. That is why we can take one example as a FAA, for example. And what happened with this kind of device? Well, the American has one way to work is all put in the books, all put in the books. They have many books for the law, and one of them is the number 14. The 14 is all involved to aeronautic and space. For example, 13 maybe is a credit card or something like that. I don't know. They put everything in different books, but it's just one library that had this kind of books. If you understand, it's okay. Easy to understand. In this book, you can pick it. Right now is electronic book, but at the beginning was always one book. It was very hard to find things there, but right now everything is in the web. You can find it. They use the Code of Federal Regulation. The Code of Federal Regulation, CFR. They use the number 14 for aeronautic and space. Inside of that, you have many different chapters. And the chapter 1, you have a Federal Aviation Administration, FAA, Department of Transportation. Easy. There you have the first one, you have a chapter A, you have definition, regulation. Well, you have part B, you have procedures, but C is very important because you have aircraft there. You see D, you have airmain, airspace, you got it all there. I put only small copy and paste because it's huge, many things. But if you see aircraft, what means? Say, this is the rule to follow for design, build, and test one aircraft. And you have many rules because all the aircraft are different. It's not the same. A small plane than the big plane. Small helicopter, big helicopter. Balloon, than, I don't know, whatever. It's not the same. It's not the same. That is why they inside of the aircraft you have different regulations. Different regulations. That is why, for example, for us the important thing is a small plane. Okay, you have 21 certification for products. Is a product? No, don't care. 23 airworthiness standard normal category airplane. Oh, I like that because it's a normal category airplanes. Yeah, we can use it because it's a small one. Because the next one is 25. 25 is transport category airplane. Huge, big, heavy. Don't care. Don't care. We can cross. Don't care about that. 27, say, airworthiness standards, normal category rotorcraft. Okay, could be. Why not? Because they take off and land. Take off and land as a helicopter. Yes, I can take it. And you check one by one, and you go in, and you have all the rules. Huge rule for every part of the plane that you want to design, build, and test. And after that, you can certificate in part 23 as a plane. What? Somebody will take a photo. Okay. Well, then you have part 23. You can certificate this plane as a plane. Yes, looks like a plane. It's a plane. You can certificate. Yes, it's okay. In 27, you can certificate this a helicopter. Yes, because all the rule is inside. Don't care right now. When you have time, you can see it. You go to FAA and see all the rules because all is free. You can go in and check it out. Well, you can imagine what happened with the urban mobility device. Is what is this? I don't know. But in any case, I pick it up my idea and go to the FAA and go there and say, I have a plane. You see? It's a plane, have a propellers, have an engine, the only problem has a battery, but we can discuss this. But it's a plane, no? Yes. They say, okay, the expert guy from part 23 planes say, yes, you have a plane. Looks very good as a plane. You can certificate as a plane. Okay, thank you. You pick it up all the paperwork and start to certificate as a plane. You can do that. Yes, why not? But when you back to the factory, in the factory say, yeah, but it's not a plane because takeoff and land as helicopter. Say, okay. I come back to the FAA and say, oh, sorry, I make a mistake. It's a helicopter. Oh, okay. You need to talk with the guy of part 27. It's a helicopter guy. Oh, good. You go with the helicopter guy. The helicopter guy say, this is all that you need to do for certificate the helicopter. Okay. You pick it up everything and you back to the factory. And the factory say, but sometimes it's helicopter, but sometimes it's plane. But you come back to FAA and say, okay, if you hear me, sometimes it's plane and sometimes it's helicopters. Depends. And they say, okay, but this is not the way to certificate. Or you certificate a plane, or you can certificate a helicopter, but not both in the same guide. That is why here appears the problem. And the problem is the helicopter describe how to fly, how to design, which is the condition to do an helicopter. If you read there, say, this part prescribe airworthiness standard for users to type certificate and change to the those certificate for normal category, normal is a small one, rotorcraft with maximum weight of 7,000 pounds or less, and 9 or less passenger seat. The helicopter can achieve that? My device there? Yes, it's a helicopter. Yeah. But why I put it in the right side a caterpillar? Because the caterpillar has a big mysterious way to change. The change is he can fly too. Means that right now we can change to another certification in a normal category. In this kind of device, certification in the normal category applies to airplanes with a passenger seating configuration of 19 or less and a maximum certificate takeoff weight of 19,000 or less. If you see, the difference of concept is huge. And the difference in concept remain huge in all page that you pick it up in both law. If I have the certification for 23 and 27, I don't want to be deep in this matter, but it's important to know that you have an helicopter and fly in the same guide. But the certificate, the authorities don't care. They always all his life say, or it's a plane or it's a helicopter. In the middle do not exist. Say, yes, but my device can convert. Say, okay, but we have a problem right now. And the problem is, right now, because we don't know when we put this kind of certification. Is 23 or 27? Because the butterfly and the caterpillar is the same guy. Mr. John remain being the same guy. Understand the concept of the problem. The concept of the problem right now is what we need to do for certificate or for be feasible this kind of transformation in the air. Because if we saw in the past, this device exists really. For example, the Augusta Westland 609 exists, and Augusta Westland is the plane that can convert to a helicopter. Okay, this exists, but they use a small tricky in the law. They use, if we come back, they use part 21 because they think that it's the only case in the world, or maybe another one, maybe two, that can pass through this regulation. They make a special regulation, it's part 21.17. If you look in the FAA web, you put FAR 21.17, yes, you have the certification, the special condition for this just one plane helicopter in the world. But in this case, you have you have a lot device that they are trying to pass through the regulation, but no one can pass through this kind of regulation, because every exception that you make in the rule, you need to put a lot of people in FAA or EASA to working on it. And right now, the FAA has a lack of people in the company, a lot, yeah. Right now, if you wanna make a license or permits or whatever in FAA, maybe you spend a lot of time to do it because they are looking for people for work there, because after pandemic and recession, they lose many people for they left the work, and right now they don't have. That is why they need to make the emergency to make a new rule, the new rule for that. Well, if you see now, this is the new definition about that what happened in the industry and in the government about the new regulation. The new regulation say urban mobility enables high automated cooperative passenger or cargo carrying air transportation service in or around urban areas. UAM is subset of advanced mobility, air mobility concept under development by Federal Aviation Administration, National Aeronautic and Space Administration, and industry. That is why I put in bold industry, because industry right now is the most source of pressure that the government has, because they are put a lot money for push in this direction. That is why right now FAA and NASA are working very hard to provide solutions for this kind of device. Well, the government say, well, AMM has the potential to achieve the vision of transportation that is more efficient, more sustainable, and more equitable, will creating thousands of great jobs. This is very important in FAA, because in Europe this don't care, but in America this kind of things move the people to do things. That is why they announce in this way. When they put thousands of great jobs, this move the people. Europe is not the way, but in America, believe me, is the way. Well, this goal is CONOPS is to provide common frame of reference to support the FAA, NASA, industry again, and another stakeholders. Another stakeholders means another stakeholders is Vertiport. They are putting a lot of money and they want to receive helicopters and urban mobility device. That is why they're pushing and pushing. Well, they are challenge technologies, don't care about that. I put two reference there in FAA and EASA. You have there two reference that you can go very deep in that. You have many pages to read. If you want, you are free to do it. Well, at this point, the one thing is very important to know is that China, they make a one step forward. That means one step forward, because they declare we make a new rules. The new rules, they say guidance on they say UAV. No, not they call UAV. They call it like that. They say guidance on UAV airworthiness certification, but they are based on operational risk. This never happened. Never happened in the past. Never. Because they admit right now that the certification keep forward in base a operational risk, they take a risk to certificate aircraft that is not almost 100% developed. Understand, this is a huge forward step for the industry. Huge, eh? It's not this, because no one, FAA, no EASA, CAA, from France, any one of them take this operational risk in any law, because EASA, FAA is based, the basement of the FAA and EASA is two words, is safety first, always. Safety first means the operational risk, this is not the good way to take this kind of decision. That is why China make a big step forward for move this device in the cities, and now they are requiring many devices for flight. They are moving very fast in good way. Well, we will see it's good way. Maybe they are taking many risks, but for us very good, because the risk will be in China. Don't care. Means we can move to the, because the time has passing this. The time is okay for you, Fabio? Fabio is sleeping.
No, I'm here.
Okay, wake up, Fabio. I am close to finish. No, the time is okay.
It's up to you, no problem.
Okay. Well, we talk about this is important for you because I talk about the vertiport.
Okay.
Okay. Well, for move the device, we need to some place to recharge the battery, change the people. It's not any place in the world. Must be exactly the place, because we need to move between corridors. At least I don't think that this kind of vehicles can fly freely. I don't think so. They must move in corridors and different altitudes and different conditions. But for land and takeoff, they need a base. The base, they call this kind of building, they call as vertiport and vertistop. It's a new definition. If you see the pictures, looks very weird, and the top, because we have two pictures. One is the old picture from the 60s, and the new one in another side, and looks almost the same, almost. When would they have 60 years of difference from the cartoon to the reality. Well, is one interesting thing. Well, for this kind of vertiport and vertistop has two definitions. It's very easy. Vertiport is a port that can contain everything that you need for operation. An area of land structure used to intend to use an electric, hydrogen, and hybrid vertical takeoff and landing for landings and takeoff. A vertiport can include association buildings and facilities. Could be, I don't know, for taxis, for normal taxi, for car, for you have many conditions for that. Then vertistop is almost the same, but without many facilities. Only is for change for boarding and discharging passenger and cargo. You only stop and continue. You can change only person and cargo, as I say. Well, conditions. I go faster because if not, you kill me, Fabio. This facility has many conditions to be built. For example, vehicle charging system that convert the high power energy from the net, and to reduce the voltage and the power to connect the device. You must have vehicle charging system, convert high voltage transmission to line to low voltage, elevator to stairs, passenger shelters with furnishing, normal to be to have a good time there. You can have automobile parking if you arrive with your car or in a taxi. Lighting system, you need to passenger areas, landing pads and taxiways. Well, IT system, security system, power grid upgrades, water system, aeronautical chart preparation. That means that you can select the place that you want to go. All will be automatic. Maybe use mobile phone. I don't know. All born short time ago, and we are looking for a system for battery recharging and spare. Maybe you can change the battery, no charge, only change the battery and continue. Spares inspection cost no is inspection is for example maintenance of the device, of the batteries or whatever. You must to have a place, and all the place must to be soundproofing, because the people don't like to hear the noise outside. It's a good place to live there, to pass through there. Well, city. About the preliminary study of the city, is if you want to put the vertipad or vertistop there, you must study the feasibility of the project. Means what kind of congestion you have there. If no congestion, don't care. The invest money is a lot. That is why you need to think in big. You need to check the population density. Which is the existing transportation industry, regulation on ground and air is both are important. What kind of regulation for the vertiport? What kind of regulation for flight? You have many regulation in every country. You must study that. Business and commercial aviation, what happened with that? Because maybe sometimes it's better if you pick it up a plane, if the long distance or helicopters, you have a challenge there because you have a competence. Gross domestic products, you need to analyze too, because it depends of the project. Local politics and their policies. Some place looks very good for invest, but maybe they are very rigid. For example, Europe is too rigid for this kind of device. Will be the last to adapt this device for flight, I think, because here the bureaucracy is too huge and it's too rigid. But they are very open-minded. More than is ecological way, because here all is eco, the cars and the cities, and maybe you can contrast there. You need to check the per capita income, cost the vertistop. This is huge inversion. And one very important thing is, if you put in the certain city, this is well, you have a real estate high cost in the, for example, New York or I don't know, Paris. The real estate there is huge. You must to analyze that, and well, all kind of taxes that apply for your company. Well, this is at least the small presentation that I did, and this is the almost the past and present of this kind of the future that we are looking for. But we have many challenges for the future, many challenges for the future. And I divide in 5 in the power, batteries. You talk about that, are heavy and slow to charge. If you use a fast charge, we destroy the battery very fast, maybe 400 charge, you destroy it. You have degradation, means that every time that you charge, you use less battery than before. If you use, well, you can use different combination for the dangers of the battery, because right now it's a little bit dangerous, but this increases the cost and weight. We have many problems that what happen in case of fire in flight, because this kind of battery, when it start, never stop. It's dangerous right now because the battery can explode or enter in fire alone. It's not common, but what happens if we don't have the solution yet? In the event of more the one engine failure, what happened if we have, for example, 4 engine that has one of them fail or 2 of them fail? What happened? Which is the safety mode. How manage the temperature of the batteries? Because this is the key factor for the battery life. If you keep in the, for example, 25 or maybe 30 degrees to between 50 and 30 degrees, you have a big life of the battery. But if you put more than 32, 33, you couldn't call it. You couldn't cool down the battery. Immediately, the temperature goes directly to the 90 degrees and burn up. That is why it's very important how manage. Right now, the good way to manage this is use less C. C means the quantity of the capacity that you can use during charge of discharge. Normally it's 5, 10, 30, depends of the battery. Well, but this is enter deep in the problem. Right now, you are the future, you are the new engineers in the world, and you have this challenge for pass through in the no more than 10 years. And you must resolve this. The avionics, the same. We have current radar technology, but beers, wire bundles, helium balloons, urban environment is a problem for us right now. The avionic from interact with new avionic for interaction will be used, should be created. New rule, new interaction. I said with telephones, with tablets, with computers. I don't know how will be the future about this. How the business will be in this case of device. How much redundancy we need to have, because every redundancy we need obviously will be, because if not, nobody certified this kind of a device. But for redundancy, every redundancy that you put is weight that you install, and the weight penalize the batteries and the flight. And the mobile phones, for nav, select change vertical port. We don't know yet how we'll manage, because right now every company proposes different solution. But about the future is the new challenge. Will be the natural device to use for program the flight and the vertiport. We will see. Air traffic. We have a lot challenge in air traffic. Is who will control the air traffic? We discussed it before. Will federal, state, and local agencies share power over them? For example, if you change the border, who is manage this? It will be all the state manage one, or one of them manage every part. We don't know yet, because it's the beginning of the law. We discuss this, is be able to device will be flying freely or through corridors. I think will be in corridors. It's not yet designed. How they can safely integrate into the air traffic management ATM network, because do not forget that the planes, helicopters, huge plane, huge helicopter continue flying, balloons. How can integrate all together? Well, NASA, DARPA, and FAA are working on it. We don't know exactly what happened with that, but at least it's a future, not present. But if for you guys, the future is yours, not mine. I am working in at the present right now, but this is all this question will be for you. You must work in that. ATC is the same. Are the passengers willing to accept the flying with a pilot? Oh, this is a good question. Are the passengers willing to accept a flying with a pilot? Oof. Not me. Not me. Maybe the young generation, yes. But for us, it's very complex. Very, very complex. Even in the airport, when we pick up the train with a pilot, we scare too much. And just is a train. But I don't know. I don't know what happened for this kind of acceptance of the public. Even when you fly in the place that you have people inside of the device and people in the street. Well, will be very, very complex to accept, but the industry is working on it. Well, regulation, where it's going, well, almost everybody knows, but nobody knows exactly what will happen. The timeline, nobody knows. The industry is pressed too much about that. The second question is non-conventional device. It will be easy to certificate? No, but they are doing many rules right now for certificate. As I told you, China, they put a big step forward. They will take a risk. It's a huge step. It's not it's not the common way to do the rules, but they are doing. Okay. For us, it's very good. As I told you, the industry is pushing forward. Can FAA and NASA give the size? Oh, the future will see. They are not confident to release regulation right now because they need to thinking about all the way to screw it up. That is why they're taking time. They are thinking about, but many people still working on it. It's not easy decision that they need to take. Well, for example, I explain this. Why do not they capable to use FAR 2117 with Leonardo 609? 609? Well, I don't think so. This I can erase that because it's almost impossible because this was one law just for one aircraft. Is the method of acceptance is a little bit weird and nobody passed through the whole again. I think that this almost is ready to erase. And the question is why China take a risk? It will be a good or bad example? Nobody knows. Maybe the future could be a good example, or not a bad example, because for the future development, everybody try to press for this way, and the future will be. And for ground infrastructure, they will charge or solve the batteries. I don't know. Can the electric grid support? This is very important. Can the grid support the grid? Electric grid, it means the electric that come from the electric factory, no? Support massive new energy demands. Oh, I don't know, because with some the electric cars, trucks, train, and now airplanes or UAM. I don't know. Maybe no. Maybe it's not prepared yet, but I think that they must to be serious with that, because if not, all the time if everyone has a electric car and everyone has I don't know, a truck, electric truck, all the companies or this kind of device are flying as so crazy in the urban territory. I think that the city start to collapse in energy demands. And here in Europe, it's worse because they decide to not use anymore atomic energy, and this is a big problem here right now. That is why the energy increased the cost too much. Well, but this is future problems. My problem right now, don't care. Oh, Um, maintenance facilities, emergency landing. Oh, how the human air mobility maintenance facilities will do? Well, maybe it's a normal one, could be. Emergency landing spots. This is very important because what happens if you are flying and the device entering emergency? I think that he can take decisions to go to one spot, but this spot nobody thinking about right now. Or maybe in the future somebody makes some spot in the city for emergency landings. Could be some parking areas, from car parking areas, or put a free zone for a spot. Could be. I don't know. It's not designed yet. Is the question for the future. Well, the cost, who will, well, this is the common sense. Who will pay? Not me. Will city neighborhoods we welcome to or reject the new area? I don't know. This can say, well, we can manage this question the same with the passenger willingness to accept the flying without a pilot. Maybe it could be the same. The acceptance of the public of this kind of device, take it time. It's not for tomorrow. But well, right now, the future is right now. The cities of the future, somebody is thinking about, will be green, will be all electric, with this kind of device. And I don't know, until now, this is my presentation and my present. Right now, the future is yours. That is why I say many thanks for stay here. See you in the next future Dreaming Flight.
Thank you so much, Professor Rafael, for your knowledge regarding the future of urban air mobility. We have some of our attendees which have put in some questions. So one of the questions from one of the attendee asks, what is this is related to the power part of the UAM. What is the
Yeah.
approximate size of a hydrogen cell that can be used?
Oh, the hydrogen?
Yes.
Well, it's very heavy. Of the problem is the weight. The weight for hydrogen is we experiment with the Skywalker. We put the hydrogen inside, and it's a huge device because you need a steel high pressurized tube that the weight is almost 35 kilos, full charged. The device to convert, well, the hose and everything. The device to convert maybe has 11 kilos more. And after that, you need to put a radiator for dissipate all this energy. You think that 50% of energy you need to dissipate. Means that the radiator that you must install maybe has another 20 kilos. It's right now it's not feasible to work with that. Right now. Maybe in the future we use a carbon fiber cylinder, but it's almost the same weight because in the middle you have a cylinder. It's aluminum cylinder that you put carbon fiber, a lot carbon fiber, a huge quantity because they resist maybe 17,000 PSI. It's a huge one. Or it's dangerous. Yeah. Right now it's a nightmare. That is why we are thinking about the future. No, the present is not feasible to solve it right now.
Okay, thank you. One of our attendee asked one more question. The attendee asked, what is the future of the TMA in relation to licenses and qualifications?
Sorry, repeat because I hear very. You can put.
Yes, one of the attendee asked, what is the future of the TMA in relation to licenses and qualifications?
Oh, license and qualification about well, pilot, forget. You know, you are talking about engineer and mechanic and everything. Well, I think that we will remain the same. You are talking about that, no?
Yeah.
Yeah, pilots. Sorry, but forget about that. It's no word for a pilot. Will be a word for, yeah, mechanic or operators. FAA do not express any intention about that. It will, because maybe the law is covered. Because when you sign a helicopter or plane, it's the same sign. You don't need a special condition. Maybe EASA is a little bit more complicated about that. Maybe making new rules for repair this kind of device. Right now, as a experimental aircraft, don't care. You can sign it as a mechanic. But in the future, if you put the people inside, yes, the rule must change. In EASA, there UAA, you have affected by EASA normally, and they have many, many rules for mechanics. FAA do not have. FAA, you're a mechanic, you can do whatever you want. You sign, it's your life. But in EASA, you have B1, B1.1, B1.2, B1.3, B1.4, B2. It's complex. It's complex. I don't know. The bureaucratic system in EASA is too complex, but they made the rules, not me. Maybe they make a new rules for mechanics or engineers. Engineers, I don't think so. Nothing changed. But for mechanic, could be that they make new rules for maybe will be B3 or B4. They have many imagination for invent numbers.
Okay.
Never know.
We
In
have
EASA, never know. Sorry.
no problem. You can continue. Okay. We have another attendee asking one question. The attendee asks, "What is your opinion regarding these modern vehicles that can change between plane and road vehicle? Does that represent a problem for urban aeronautics? Taking the air car as an example, which you must have seen in news."
Well, Eric, well, their car always was a dream. It's the same. Everything born in a dream. The flying cars come from the maybe before this kind of taxi. Maybe come from the 40, 15. When they have cars, say, I want to fly with a car. They invent many devices to do it, and nobody can reach it. But right now, with the new technology, you know, carbon fiber, new metals, new technology that we have with batteries and everything, we can fly with a car. But right now in the city, it looks very weird. That has this kind of device, because you are the car do not hide the wings. Maybe can fold it, but you never can hide them. That is why it looks very weird. If for fly plane, normally if you are a pilot, you make a pre-flight inspection. You know what I mean?
Yeah.
If you come, for example, if you park the car in front of I don't know, McDonald's, and the boys started playing with the car, and I don't know, broke something in a wind or whatever. You sit in your car and say, when you arrive to the highway, you say, oh, I want to fly, and put the wings and fly. But you never know that the wing is broke. Understand?
Okay. I think
In any case, you must to do a pre-flight inspection for a flight car. Then you must to stop and check for many things to do. If not, you don't have the security of the confidence that you can fly safely. This for the authorities banned. You couldn't fly it. That is why it's another way. But I think in the future I think in the future it can exist, because it's an old dream from the humanity.
okay. So I have one last question. So I'll share with you one last question from one of our attendees. The attendee is asking for some of your thoughts. What about safety procedures for passengers in case of emergency? or during an emergency evacuation when you have no crew? Who will take care of them in such cases?
Well, you tell me, because this is the future. In the present doesn't exist. That is why the problem of certification. You will, yeah, maybe in 10 years you call me and say, hey, Rafael, I know the solution. I have the solution. But right now it's future. That is why it's one of the last questions that they have. What happened in case of emergency? What happened? Maybe it has a parachute, but parachute maybe will be a huge one because normally you are flying maybe in 300 feet or 500 feet. You don't have time for that. For a helicopter, in this kind of condition and in hover in 300 feet, you stay inside of the dead man curve. You know what I mean? Dead man curve. If something wrong happen, you see a lot in 3 minutes. Understand?
Yes.
That is why many questions that we have for this kind of device, that is why it's a future. But I don't have all the answer, believe me. You will have the answer, not me.
Um, so that concludes the questionnaire part of today's session. So as we draw to the conclusion of this inaugural session of New Talent of Future Aviation 2023, we extend our heartfelt gratitude to Professor Rafael for sharing his profound insights into the future of urban air mobility. Today, we have embarked on a journey of knowledge that not only explored the cutting edge concept of urban aerial mobility, but also benefited from the expertise of a distinguished professional like you. Professor Rafael's extensive background in this topic added a unique depth, in my opinion, to our understanding of this particular subject. So, on behalf of Aviation Engineering Society at Emirates Aviation University, we express our gratitude to Professor Rafael and to our other guests and attendees for their active participation. As we conclude this session, let the lessons that we learned today propel us towards a very positive future. Thank you so much.
Thank you to you, Mohammed, and thank you for all. Well, we will see the future maybe.
Thank you. Yes.
Y no lo podía creer, había aprendido un montón. Entonces, bueno, él me contagió mucho la pasión también por el tema de helicópteros y la aviación, de llevar un pedazo de metal a hacer algo que vuele, con lo cual eso me picó muy hondo y hasta el día de hoy que yo sigo con todo esto. Bueno, después me fui a Estados Unidos, reparaba helicópteros, estuve en Oman, en Arabia Saudí, en otros países haciendo todo tipo de trabajos. Y ahora estoy con Skyweller, que es la empresa que trabajo, y hago colaboraciones con algún que otro piloto o proyecto que hay en Estados Unidos, de forma, digamos, ad honorem, pero que son amigos y se lo merecen.
Augusto Sicaré tuvo un sueño: construir su propio helicóptero. Esta ilusión poco común se hizo realidad cuando tenía 21 años, allá por 1958. Después de intensas jornadas de pruebas, dedicado por completo al trabajo en su taller, la ciudad de Saladillo asistió a un hito. Augusto había logrado su cometido y todos vieron volar al primer prototipo de Sicaré CH-1.
En Saladillo yo encontré una escuela de vida y una escuela de ingeniero. Y eso me marcó bastante para mi carrera actual, ¿no? Otras cosas marcó mucho mi familia y mis amigos y otras personas, pero particularmente para el desarrollo me marcó mucho el haber pasado por Saladillo y conocer a Sicaré y su familia, que me han tratado, la verdad, que como un hijo más, siempre.
¿A qué te referís cuando decís una escuela de vida?
Empecé a aprender que lo simple era la solución. Yo venía de la escuela de que lo complejo era la solución. Y empecé a ver que lo simple era la solución. Y la buena era la simple. Y en todo sentido, en relaciones humanas, en en lo que era la parte de ingeniería, en la parte de soluciones, eh, de siempre los problemas que han tenido ahí son infinitos y siempre con buena cara. Entonces, esos pequeños detalles te hacen que te cambie tu manera de pensar a veces cuando tú tienes algún problema, ¿no? Yo era muy atolondrado, muy echado para adelante. Me equivocaba muchísimo, me sigo equivocando, no te preocupes, que eso no lo voy a perder. Pero en hacer ciertas pausas, en pensarlo, en vez de hacer una prueba hoy, la hago mañana, voy a esperar, me tomo mis tiempos. Para armar un equipo, yo las entrevistas a mis chicos normalmente le hago 5 entrevistas, los reviento, pobrecitos, porque una cosa es contratar a alguien y otra contratar a alguien con el cual conectaste. Si no conecto, por más que sea quien sea, no me hallo en un equipo. Y eso, eso creo que lo aprendí un poco ahí en Saladillo, de cómo primero conocer a la persona antes de embarcarte en algo, ¿no? El conocimiento está. En este tipo de proyectos no te tienes que preocupar por el conocimiento. El conocimiento está. El problema está que el equipo no funciona. Ese es tu tendón de Aquiles. Si el equipo no funciona, o el equipo no te sigue, o no te respeta, o no se respetan entre ellos, o no respetan a los otros departamentos, tienes, por más que contrates a quien contrates, no te va. Traes un premio Nobel y no va a funcionar.
¿Y qué significa, Rafael, para vos trabajar en esto? Porque hablamos de energía solar, estamos hablando de calidad de vida, de nuevas energías, de nuevas formas de pensar el mundo, de pensarnos nosotros en el mundo. Hablar de inteligencia artificial también es algo innovador que aún hoy, digamos, que tampoco es masivo y que también genera ciertos cuestionamientos o debates o tensiones en la sociedad.
Sí.
¿Qué significa esto para vos?
¿Qué nos depara el futuro? No tengo
Claro,
ni la menor idea. Eh, ¿Cómo va a ser? Supongo que en la revolución industrial la gente se hizo la misma pregunta. Y todavía estamos todos con trabajo y todos viviendo. Los que están en el tema del desarrollo de lo que es inteligencia artificial son los que están en este tema. Yo lo que les propongo o los que les facilito es la solución o el vehículo donde
donde se
esto va a
aplica
funcionar.
eso,
Si fuera
claro,
un coche, yo me dedicaría al coche y ellos pondrían su cerebro inteligente ahí adentro. Yo lo único que haría son por así decirlo, las conexiones neuronales, que es lo que
claro.
hago. Estamos en un nivel tecnológico bastante avanzado, que todavía no es práctico. De los taxis aéreos, de todo esto que se está generando, que son como 600 proyectos en el mundo, de los cuales cuántos sobrevivirán, solo Dios lo sabe. Porque esto no es que cuando salió el coche, imagínate que se hicieron 200, o sea, todo el mundo quiso hacer un coche, y cuántas marcas tú conoces. Son muy pocas. Esto va a pasar lo mismo, porque es una cuestión de mercado o de funcionamiento, o quién da en la tecla y quién no. Yo esto lo vi en Estados Unidos cuando estaba ahí. Antes de eso, en la década del 90, salió algo que se decía que se iban a hacer autopistas de baja altura, y quién no había visto Volver al Futuro. Entonces, para los que nos gustaba la aeronáutica, sabíamos que esto venía, sabíamos, o sea, los que estábamos a fin de la década del 90, ya sabíamos que esto venía. Pero al fin y al cabo, esto es como, a ver, como te lo explico en un proceso físico. Si tú pones un hielo, o sea, un hielo en un vaso, y tú lo calientas, nunca va a pasar de 0 grados hasta que el hielo no desaparezca. Eso se llama en física calor latente de fusión. Yo creo que eso es lo que está pasando con la tecnología actual. Se está invirtiendo una cantidad inmensa de dinero, pero inmensa, de miles, hablo de millones, y todavía los resultados no están a la vista. El taxi aéreo no existe, pero el dinero se está poniendo en todos los proyectos. Cuando esto madure, cuando termine de funcionar, ahí sí tendremos los resultados.
Y en el caso
Eh,
del avión del que hablamos, digamos, energía solar, ¿cuáles son los tiempos?
Esto funciona y es efectivo, con lo cual por eso te digo, esto no tengo problema, o sea, ya nosotros lo tenemos operativo, full operativo. Entonces, ¿que va a funcionar? Sí, ya funciona, eso lo tenemos activado, pero ¿qué pasa? ¿Yo te puedo hablar de un avión solar de transporte? No. ¿Te puedo hablar de un avión solar que va a cumplir unas funciones como cualquier otro avión? No. ¿Por qué? Porque sus velocidades son muy bajas. El sol no entrega tanta energía como la gente cree, entrega muy poquita. Hay que tratar de agarrar todo lo que puedas del sol, que ahora estamos en 27, 31%, que sigue siendo bajo. A pesar de que entrega muy poco, tenemos muy poco rendimiento, con lo cual las áreas de la sala son muy grandes. Entonces, eso hace que la velocidad del avión, como tú haces, digamos, una pancarta voladora, la velocidad del avión es muy baja. Entonces, si para el avión irme de España a Argentina en un avión solar, pues me tendría que llevar muchos almuerzos, muchas cenas, ir ligerito de peso y tardar una barbaridad de tiempo. Entonces, las aplicaciones que la gente cree de un avión solar todavía no existen. Pero
Claro.
las aplicaciones que nosotros estamos entregando sí ya existen, ya son reales, ya son comerciales y en eso estamos trabajando.
¿Cuáles son las características físicas del avión en cuanto a metros, capacidad?
Te, te voy a hablar en comparación. Tiene las alas, el tamaño de las alas son como de un Boeing 747 que casi todo el mundo lo conoce, que es el avión Jumbo. Jumbo lo conocen todos. Hasta un niño sabe qué avión es. Las alas miden 72 metros, que son prácticamente lo de un Jumbo que está en 74 metros. Después tiene el peso de una furgoneta, ¿cómo se llama? Una camioneta, 2.500 kilos, con toda la carga incluida. Y después los motores tienen la potencia de un scooter, ¿cómo se llama? De una motoneta. Son 19 caballos, 18 caballos en despegue. Después en vuelo usamos 8, 7, 10, depende si queremos virar o si que vamos en línea recta. No sé si has tenido la oportunidad de subirte a un Tesla, un coche Tesla. El coche Tesla, vos te sentás ahí y le dices, vamos a la casa de la abuela, sabiendo dónde queda la casa de la abuela, ¿no? El coche
Sí,
previamente. Entonces, el auto lo que va a hacer, vos no vas a tocar nada. Vos te sentás y no tocas nada. Y el auto te va a llevar a la casa de tu abuela por el camino más conveniente que él crea. Eso es la inteligencia artificial aplicada en el coche. La nuestra es básicamente lo mismo, pero en vez de ir rutas y carreteras va a ser destino, tormentas, vientos fuertes, cumulonimbus. Tú tienes un montón de factores que van a estar solamente en el aire. Entonces, él va a elegir su mejor camino. Pero nunca va a perder la comunicación con tierra. ¿Por qué? Porque en cualquier momento tú puedes cancelar y decir, no voy a lo de la abuela, voy a lo de, no sé, tu primo. Y automáticamente va a cambiar de dirección, va a ir a otro objetivo.
claro.
Entonces, vamos a suponer que en España hay un incendio, está sobrevolando Cantabria y hay un incendio en Galicia. Y el avión, tú le dices, el incendio está en Galicia, ve a Galicia. Y él va a ir a Galicia por la mejor ruta que él vea conveniente. Recuerda que este avión, por ser tan liviano, tiene que elegir rutas suaves. No se puede meter en una tormenta o puede hacer lo que quiera. Entonces va a subir o bajar o va a ir por el lugar que él le convenga, pero él se va a poner en el punto que tú le dices.
¿Llegaste a hablar de algunas de estas cosas con Sicaré? ¿De lo que se venía?
Sí, sí, claro. Sí, claro. Yo hablaba por teléfono semana por medio con él. Claro, claro, sí, sí. Y bueno, sí, claro. Sí, charlas largas, largas. Después de un año que ya se nos fue, las extraño un montón. A veces quiero hacerle preguntas y no tengo a mi maestro.
¿Cómo lo vive también tu familia, ¿no? ¿Cómo es la rutina de un investigador, digamos, de trabajar con estos proyectos?
Bueno, la familia, ahora estamos un poco separados los días de semana, porque no estoy a 200 kilómetros de casa, y bueno, lo vamos llevando. Ahora, pues, he tenido a mi hija trabajando conmigo, mi hijo ahora está conmigo, con lo cual me hacen, digamos, soporte familiar. eh, y bueno, mi mujer, la verdad que una luchadora, porque me sigue a todos lados, es difícil. Aparte estudio, normalmente siempre estoy haciendo algún máster o estudiando afuera o haciendo algo y nada, todavía no me ha echado de casa. Estudiar ingeniería es una pregunta que normalmente le hago a los ingenieros acá, sobre todo en España, tengo americanos. ¿Qué pensabas el primer día que entraste en ingeniería? ¿Qué era lo que pensabas? No sé, yo estaba fascinado porque yo estaba con motos y todo esto y era el momento de adivinar. ¿Qué hacíamos? Tocábamos una parte de un carburador, por así decirlo, y funcionaba bien o mal. Pero era adivinar, era una cuestión de adivinación. Y yo el primer día pensaba, digo, me van a enseñar todo lo que no sé. Entonces yo estaba bastante apasionado en la universidad, en ese sentido. Pero tenés que tener en cuenta que vas a chocar con matemática, vas a chocar con física más o menos en particular, vas a chocar con cosas que no te van a gustar. Y para mí era una pérdida de tiempo, yo quería dejar. De hecho, he tenido muchas crisis dentro de la universidad porque a mí no me servía. Hasta que pasa el tiempo y te das cuenta que todo te servía. Y es buenísimo, y es buenísimo. Y el tema de ser ingeniero, eh, a mí me sirvió por el hecho de pasar exámenes. O sea, ser ingeniero o no ser ingeniero no te cambian absolutamente nada. Pirincho te lo puede demostrar. No te cambia nada, no sos ni más ni menos que nada siendo ingeniero. Lo que sí te da es ese coraje de enfrentarte a exámenes, a profesores difíciles, a situaciones difíciles, que después te van a servir en el futuro. Si no los pasaste, el futuro se te complica, porque, excepto que tengas un carácter muy particular, no te vas a animar a ciertos retos. Entonces, estudiar siempre está mejor que no estudiar, siempre, siempre, siempre. El pasar retos es lo mejor que te puede pasar, aunque sean dolorosos. Para mí, no sé, ciertos exámenes fueron terribles, pero bueno, después de pasarlo fueron un muro. Y después no escuchar a nadie. Esa es la realidad. Cuando tenés una idea o tenés una idea de futuro, no tenés que escuchar a nadie. Pero ni los que te hablan de bien ni los que hablan mal. Porque si no, no vas a hacer nada. Entonces, tenés que ser como una bicicleta con piñón fijo. Y en ese sentido es no claudicar. Que te va. Yo, yo llegué acá por la suma de todas las cosas que hice mal y los fracasos que he tenido. Fueron todos. Por eso llegué aquí. Entonces, tampoco me siento que he llegado a ningún lado. Recién me siento que estoy empezando. Tengo ganas de hacer un montón de cosas. Tengo un montón de ideas. Normalmente estoy dibujando en mi ordenador cosas que estoy haciendo de forma particular o con algunos amigos. Siempre estoy haciendo algo. Pero si yo escuchara o me viera desde afuera, diría, pero pará, no estés tan loco, quédate quieto y disfruta un poco más, sal a pasear con el perro, no sé, una cosa así, ¿no? Que al final lo hago también.
Sí, sí, sí.
Pero, pero el tema es no claudicar.
Ujú.
Es una cuestión de satisfacción personal y de estar bien con tu familia, tus amigos y no sé, y tener esa sensación de tarea hecha. Entonces, que cuando la tarea está hecha ya te pica hacer otra, ¿no?
Sí.
Eh, yo ya tengo en mente otras cosas que voy a hacer. Esto del avión solar es una cuestión de que obviamente estoy muy bien, estoy genial, pero ya me pican otras cosas. Y estoy en ello también, ¿no? Obviamente. No te puedo contar, pero ya te contaré otro día.
Que hay uno de tus trabajos que estás haciendo con algunos profesionales de La Plata, la producción de hélices.
Bueno, hay un proyecto en particular que estoy trabajando, bueno, que es de aquí el proyecto, es un proyecto internacional en el cual hay una empresa de La Plata que está aportando todo el desarrollo y todo el trabajo.
¿Y qué es lo que se está produciendo en La Plata?
Se está haciendo todo el desarrollo de una hélice de alto rendimiento eh, eh, con unas especificaciones bastante complejas. Nosotros tenemos una hélice alemana y el rendimiento que está dando la nueva hélice es mejor que la que tenemos actual, así que estoy muy, muy ansioso por verla. Por ahora se está trabajando en el túnel de viento y bueno, tengo poca información por ahora, porque la verdad que tengo muchas ganas de que esto suceda. Ya sabes que soy platense en todo sentido.